Okay, here we go. Section 8.2. And we already talked about this, but it is called the Pythagorean Theorem. Pythagorean Theorem. It's named after a dude. Named after an old, I guess he's a Greek guy. I don't know, he sounds Greek, doesn't he? His name is Pythagoras. I'm going over it again. How about that? His name is Pythagoras. And he didn't actually... I heard somebody say this the other... Where did I see this? I don't think it was online. I think I saw it on TV or something like that. For some reason, they were talking about Pythagorean Theorem. They talked about Pythagoras, and then said, oh, he's the guy that came up with the Pythagorean Theorem. And I was like yelling at the TV. Not really yelling, but I thought to myself anyway. I was like, no, he's not the one that came up with it. They actually knew about this theorem before Pythagoras. Did you know that? They had actually known about this. So they knew a squared plus b squared equals c squared. But Pythagoras was given the name, or the theorem was named after Pythagoras because he was the first one to come out with a really good, solid proof of the theorem. Okay, it hadn't really been proven in a good, acceptable way, I guess, and he's the one that gets credit for it. All right, not because he came up with a theorem, he didn't think of it. He just came up with a proof for it. So they actually knew about the theorem before him. All right, so I think that's an interesting tidbit of information. Now look, I understand that you guys are well familiar with the Pythagorean theorem, so I'm just going to go through it quickly here, but there is a little bit of extra to this that I want to make sure that we hit that you probably didn't realize. All right, so Pythagorean theorem only relates to a right triangle. You can only use Pythagorean theorem on a right triangle. A lot of people use Pythagorean, or they try anyway, to use Pythagorean theorem on a non-right triangle, and it can't be done. Only on a right triangle. We'll call the legs A and B, and we'll call the hypotenuse C. Which one is the hypotenuse? It's the one opposite the what? The right angle. Yeah, let's say it the right way. So it's opposite the right angle. Excuse me. So C will represent our hypotenuse. The A and the B will represent the two legs. All right, and then the theorem, there's a lot of explanation on how to get to the theorem, but I'm going to just do it like this. Now, most of you guys are used to hearing it, a squared plus b squared equals c squared, but I'm just going to flip it around, and I'll show you why I'm going to do this in a second. So I'm going to write c squared equals a squared plus b squared. It's the same exact thing, isn't it? And there you go. So let's do a quick little example. They actually have a little proof in the book, and they actually use that geometric mean stuff that we just finished doing. That's why they put Pythagorean theorem after the geometric mean, because they actually do a proof of it. I don't know if it's Pythagoras's proof or not. I don't know that much of the history about it, but there is a proof on page 541 at the bottom, and they actually use the geometric mean to prove the Pythagorean theorem. I've seen it proved a couple different ways, but that's how this book chooses to do it. So what if we had something like this? What if we, let's get rid of the A, B, and C. Let's put some numbers in here. I'm using the example straight from the book. Say that's that, and this is that, okay? And we'll say we have to solve for x. So what's the deal? How do we solve for x? This is about as basic as it possibly gets right here, all right? So what do we do? Well, x squared, that's my hypotenuse, right? So the hypotenuse is always the one that goes out there by itself. And then we take the two legs, we square them, and we add them up. All right, so this is good calculator time right here. So we've got 6 squared plus 15 squared equals 261. But is my answer 261? Is that the length of that side right there? Of course not. I mean, if that's 6 and that's 15, there's no way in the world that's 261. Would you agree? So what do you have to do? Square roots. And then we come over here and we square root our answer, and we get 16 point, let's say 2, round it to one decimal place, right? 1.5 rounds to a 2, so we'll say it's approximately 16.2. What has to be true about the hypotenuse as far as the length compared to the other two? Shorter? Well, just to make a triangle, these two have to add up to be bigger than this. That's true. But what has to be true about the hypotenuse compared to individually the other two legs? It's got to be what? What's that? Bigger, right? Is that what you said? Yeah, yeah. Okay. Just you were so quiet, I couldn't tell what you were saying. All right. So yeah, be bold, be strong. Okay. So 16.2 is bigger than 6 and it's bigger than 15. Okay. The hypotenuse is always the longest side of the right triangle. See, this is why I don't give you the homework, because that's all you guys are doing and nobody's participating in my little talk here. All right. So that's why I don't give the homework out beforehand. Let's do another one. I know what you guys are doing.
Morgan's like, look at my notes. Look at them.
Well, I'm talking generally.
It's like loud and
So if you're taking notes, don't be offended. So that's 11, that's 9, and that's x. All right, now you got to be careful with this one. A lot of students make mistakes here because they automatically see two sides and they see an x and almost, not, I shouldn't say almost. Some students, a lot of students, will automatically always put the x by itself. X squared equals whatever squared plus whatever squared. But do you do that here? No. Right, the 11 is the hypotenuse, isn't it? So that's the one that has to go by itself, okay? So the hypotenuse squared is equal to what? X squared plus 9 squared. Yeah, we'll just put the numbers in so everybody sees where we're getting this. Did I tell you the, what's that Yellow Brick Road movie? Dorothy. Wizard of Oz. Yeah.
Really?
I don't know. Look, I'm an old man. I forget stuff. I don't know. I forget stuff, you know. I knew it. I had it in my head. I just forget stuff. So anyway, hush. We did you hear the story about Wizard of Oz? They actually do the Pythagorean. Well, they supposedly. No, not that. I mean, that's true. I know, but I'm talking about math. Hush. Let's get on my topic. The Wizard of Oz, I think it's the Tin Man. Is he the one that gets the brain or something? Yeah, okay.
No, he gets the heart.
Who gets the brain? Oh, the Scarecrow guy. Yeah, okay, the Scarecrow, he supposedly recites this mathematical equation. Listen.
Oh, yeah.
He supposedly recites this mathematical equation to prove that he's really, really smart, right?
Yeah.
But if you listen to it and dissect what he says, it's not exactly true. And it sounds like he's trying to say the Pythagorean Theorem. He's trying to say that the sum of the squares of the two legs of a right triangle equals the square of the hypotenuse, or something to that effect. But he says it. I've done that before. I don't have time today, but look it up sometime. Look up Wizard of Oz Pythagorean Theorem on YouTube, and I promise you'll get that video and you can watch it. I don't know if they did it on purpose or not, but it's not exactly right. It's kind of close, but it's not exactly right. So Scarecrow wasn't as smart as he thought he was. So anyway, let's do this. 121 equals, hey, you know, being a realist, plus 81. Yeah. Yeah, but if you're going to do it, do the math right. Here we go. Minus 81, and what's that? That's 40, isn't it? 40, right? Equals x squared. I did that right, didn't I? Yep, 0. Yep. And then what do we do here? Square root. Okay, and I tell you what, let's simplify this. 4 times 10, right? That's what I would use. I'd use 4 times 10, so this is what? 2 square root of 10. Or if you wanted to put that into a calculator, I guess you could. So the square root of, oops, sorry, let's go the other way. Let's do square root first of 40. Oops, daggone it. It's not close enough. Square root of, oh, what am I doing? Stop this. Okay, square root, there we go, of 40 equals 6.3. So approximately 6.3. So look at it. Make sure your answer makes sense. What if your answer was bigger than 11? You knew it would be wrong, wouldn't you? Okay, because the hypotenuse has to be the longest side, so make sure you do that. Okay, now here's the part that you may not have known. What if I gave you a triangle? Everybody looking up here now instead of doing their homework?
Is this the triple?
I almost hate telling you to stop doing your homework to look at here, because at least you're interested in getting your homework done. Okay, but I need you to watch this. This is the converse of it. This says if you had a triangle, and if this C represents the longest side, because right now we don't know if we have a right triangle or not, okay? But the C represents the longest side, all right? And what do you think the A and the B represent then? Yeah, we'll say the two shorter sides. Okay? Everybody with me so far? Because right now I don't know that it's a right triangle. I have a triangle. I'm given some lengths of all three sides. I have to determine, is this a right triangle or not? Okay? Are you following me? Let's, is it a what? Triple?
Example 2. Use a Pythagorean triple.
Not just yet. You know, I should have got to that before I get to this, but I'm running out of time. I got to do this. I'm just trying to find a good example. I mean, I could make one up, but yeah, here we go. Watch. What if I was given the sides 7, 14, and 16, and I wanted you to tell me, is this a right triangle or not? So how can you determine if it's a right triangle? Well, if it fits this, if I take the longest of these three sides and I square it, take the two shorter sides, square them and add them up. If those two things will equal each other, then guess what kind of a triangle it is? It's a what? It's a right triangle. Okay? If the c squared, the longest side, listen to me, if the longest side squared equals the sum of the squares of the two shorter sides, right? I take the two shorter sides, I square them, I add them up. If this equals this, then what kind of a triangle will it be? It's a right triangle. Okay, let's see if it is. It's not?
No, it's 255 and 256.
Oh, okay, gotcha. Right, I was looking at something else. First of all, can you determine if it's a triangle? Alex, you talked about this earlier today. Is this a triangle to begin with? What do we do to determine even if it's a triangle? We talked about this some time ago. Take the two shorter ones, and what has to happen? It has to be bigger than the third one, right? Is 7 plus 14 bigger than 16? Yes, it is. So is it a triangle to begin with? Yes, it is. Now that we've determined that it is a triangle, let's figure out what kind of triangle it is. Okay, first of all, let's see if it's a right triangle. Tell you what, let's do this. Let's put this on hold for just a second. If c squared equals a squared plus b squared, it's a right triangle. Here's something you probably didn't know today. If c squared is less than a squared plus b squared, guess what? We can actually tell what kind of a triangle it is. We know it's not a right triangle because it's not equal, but we can actually tell what type of triangle it is, and this would be an acute triangle. See? That's something new that you didn't know before. And then if c squared is, what do you think? Greater than, it's obtuse. Exactly right. So it would be an obtuse triangle. So just by giving the sides of the three sides of the triangle, I can determine what kind of triangle it is. Notice, I put the c first, didn't I? That's why I wrote Pythagorean Theorem with the c first, because that's how I'm going to write all these formulas right here. So what we're going to do is we're going to look at these three sides and determine what type of triangle is it. Is it a right triangle? Is it acute? Is it obtuse? So what do? We take the longest side, which is 16, and we square it. Okay? I'm going to put a question mark here because I don't know if it's equal, less than, or greater than yet. Okay? And then I'm going to take the two shorter ones, 7 squared plus 14 squared. I'm going to see what I get.
It's 215.
Okay, I know. Let's just show it on a calculator then. All right, so let's go 16 squared. So 16 squared, and that's 256. 256. You got to make sure you compare them in this order, though, okay? And then I take 7 squared, which I already know is 49, plus 14 squared, which is whatever, and then that equals 245. Now, that's a weird 2. What's compared 256 to 245? It's greater, isn't it? So if the c squared, the longest side, is greater, right, than the two shorter sides squared and added up, then what kind of a triangle is this? This is obtuse. I will in a sec. Here we go. What page is that triple stuff on?
It's on 540.
540. Okay, good. All right. I might have mentioned this triangle to you at some point. I think I did. But now we officially talk about it. Let's take a look at this. There are some sides of a right triangle that come out nice and pretty and even. Okay, they come out to nice whole numbers. For example, if that's 3 and that's 4, we could figure out this, because this is 3 squared is 9, 4 squared is 16, add them up, it's 25, take the square root, and it's what? And it's 5. So this is a nice, it doesn't come out to square root of anything. This is called a Pythagorean triple. What if we had this? What if this was 6 and this was 8? What do you think this is? That would be 10. You follow me? There's other triangles that match that. Watch this. There's a 5, 12, 13. Okay? These are Pythagorean triples. It just makes things very, very easy for you. Review the list on the bottom of 542. Let me give you some problems to do.
Emily.
You guys already cheated and looked,
Emily,
but I'll write it out anyway.
um,
It's...
Wednesday.
I know, but not everybody looks. It would be nice if I could just say, look at your email, but people don't. There you go. 9 through 29. There it is. Have fun.